Discovery of proton. Goldstein in 1886 performed the discharge tube experiments with a perforated cathode. So what he did, that he passes on passing the high electric discharge through the gas at low pressure, it was observed that some rays were coming from the side of the anode, which passed through the perforated cathode and produced green fluorescence on the opposite glass wall coated with a material, that is zinc sulfide, and these rays were known as anode rays since they were coming from anode, and also known as canal rays as they pass through canals, that is holes in the cathode. So these were also called the positive rays, as we can see in the diagram that they are carrying the positive charge. So since an atom is electrically neutral, so the presence of any positive of the positive charge, there will be an issue. So we can say that the discovery of proton justifies that an atom is an electrically neutral, and we can say here in the diagram the production of anode rays, and this is the cathode rays. Here the anode rays are coming, and this is the ZNS coating, and this is a perforated cathode. Now the origin of anode rays. So the anode rays that we have seen, that they are produced when high speed electrons of the cathode rays moving towards the anode that collide with gaseous atoms, knocking out electrons from them and producing positively charged particles. So these positively charged particles moves towards the cathode in the form of anode. So the properties that we have discovered of the anode rays, that they travel in the straight line, that is linear, it has linear property, and they are made of material particles. It consists of some material, and they are positively charged gaseous ions. So the magnitude of the positive charge on these particles is found to be depend on the nature of the gas taken inside the discharge tube. However, the charge of on these particles, though positive, is found to be an integral multiple of the magnitude of charge on an electron. So these particles may carry 1, 2, 3, etc. units of positive charge. So these are the properties of anode, and also the mass of these particles constituting the anode rays also depend on the nature of the gas taken inside the discharge tube, as we have seen. However, its value is found to be nearly equal to the mass of the atom of the gas. So the experiment that I have showed that the lightest positively charged particles were produced when hydrogen gas is taken inside the discharge tube, as it is depending on the gas, nature of the gas. So the absolute positive charge on these particles is found to be same in magnitude as on electron, that is 1.6 into 10 to power minus 19 coulomb, or 1 unit of positive charge. These subatomic particles were later on called as protons. So this is how the discovery of proton took place, and it is denoted by the symbol P or simple P positive. Now the mass of proton. Now we have seen that the charge to mass ratio, that is of proton, is found to be 9.58 10 to power 4 coulomb per gram. Now we will find out the mass of proton. So the mass of proton will be comes out to be MP. We will denote it by MP, mass of proton, 1.6 into 10 to power minus 19 coulomb upon, that is the charge of proton, upon the ratio, that is 9.58 into 10 to power 4 coulomb per gram. So that comes out to be 1.67 into 10 to the power minus 24 gram, or we can say in kgs, that is 1.67 into 10 to the power minus 27 kg. So we can see that if any other gas other than hydrogen is taken in the discharge tube, the mass of the positively charged particles were found to be the whole multiple of the mass of the proton. So thus we can say that the proton is a subatomic particle, that is the proton is or are, there can be more than one proton also, that is present in all the atoms.